Welcome, everybody. My name is Francesco Santini from the University of Basel. Welcome to today's talk of the Basel Open Science Reproducibility Club. Today, we are happy to have Andrew Tyner with us. Andrew Tyner is a principal research scientist at the Center for Open Science, where he has worked since 2019, focusing on research transparency and replicability in social and behavioral sciences. He earned a PhD in political science from Chapel Hill in 2018, with research expertise spanning public opinion, political psychology, and quantitative methods, including survey research and experimental design. And his work has been published in leading journals, including Nature Human Behavior, American Political Science Review, Political Behavior, and he brings advanced statistical programming skills in art to his research on decision-making and scientific reproducibility. And today, he is going to talk about advancing automated assessment of research findings. We are very happy that you decided to join us. Thank you very much for being here, and the floor is yours, Andrew.
Okay, well, thanks all for the invitation. Thanks for being here. Excited to talk to you today about some ongoing research that the Center for Open Science has been engaged in that I've been helping lead for the past few years, talking about where it fits in the larger meta-science landscape and kind of what the future looks like in this field of research. So I'm Andrew Tyner, work for Center for Open Science. Our mission, if people don't know, is to help make scientific research more open, transparent, reproducible. And we pursue this vision in a variety of ways, offering technical and infrastructure support, policy guidance, community activation, and on my team, research about the state of research and research about reforms to improve the state of research. Okay, all that aside, uh, so I want to situate this talk first by just discussing credibility of research at a high level. Uh, I think much of this might be familiar to this group, but still worth talking about. Um, so there's been what's variously been called a credibility crisis, replication crisis, an ongoing crisis in the state of reproducibility and credibility of research across domains, right? It started with some early research in psychology and specifically social psychology, but you know, um, similar efforts across the board have uncovered similar issues in many domains, right? And so these issues tend to fall within concerns about how valid are outcomes, are they repeatable, and more fundamentally, can we even assess the strength of the science if the methods and so much of the underlying materials aren't shared, right? So some high-profile headlines in the past 15 years from familiar names. Again, this is just the context that I think all of us are aware of, right? And what's behind these challenges in credibility? Many culprits. One prominent one that gets a lot of attention is publishing pressures, right? And the disincentive this has for producing the most transparent and rigorous research. So in one explanation of how this works, right? Scientists start out with kind of a traditional goal, right? Have a hypothesis, test it, see what comes out. But then in the course of research, right, did that prediction come out? Well, if yes, go ahead and publish it. If no, well, what do you do? Well, maybe there's other findings that you can discover in your data. And sometimes those are presented as confirmation, even if they aren't, right? This is called various names. One of them is harking, right? Hypothesizing after results known, right? You're choosing a hypothesis uh, uh, post facto to justify the finding that you discovered in an exploratory way. So that is sometimes an outcome of these pressures to publish. when that fails, right, another approach is to keep tinkering with the data, to maybe not manufacture, right? That's malfeasance, but maybe cut the data lots of ways, see what comes out, and then publish selectively the results that are supportive, right? That's again, main names for it. One of them is p-hacking. And if there's just nothing that you can uh, publish in terms of positive, tidy results, what do people do? Well, they just put it in a drawer, right? And the that evidence gets buried, and then the result being the sum total of evidence for any given theory or effect is a bias sample, right? It's tending to only show the positive evidence and not the null or negative. And again, at COS and I think others, we see this. There's again many culprits here, but one of the ones that we focus most on is the incentives for novel, interesting, positive, meaning supportive, clean outcomes, right? And so, right, on the research conducting side, right, this leads to selective reporting, right, only showing the positive results or none at all. And then the various, harking, p-hacking related steps that fall under this category of QRPs, right? Questionable research practices. Um, Again, not malfeasance. It's the steps that researchers who are trying to do their best and facing very perverse incentives go through to produce publishable, quote unquote, research, right? So that's the production side. On the reporting side, right? As we know, not as much a sharing of materials, data code as we would like. And even as replication is becoming more mainstream, it is still a small portion of scientific output, right? It is not seen as central to the research ecosystem. So all of these combined, we have both literature that we suspect is suspect and also have evidence has credibility issues, and then there are no or there's weak self-correction processes uh, to improve the published record. And the outcome of all this is a lot of research waste, right? So lots of effort going towards theories that are not well-founded, which slows progress and slows our rate of discoveries of knowledge solution cures, right? The actual outcomes we're trying to achieve. There's been efforts, in the past 10, 15 years, under this reform movement or open science movement, um, to address some of these challenges, right? So better reporting and better reporting templates on the outcomes of research, uh, making the underlying data code materials publicly available by default, not on request. And then more efforts at replication, right? Retesting literature um, to evaluate the strength of existing theories and see those boundary conditions. So these are positive steps. COS is obviously advocates for these, helps research them, contributes to them. So these are part and parcel of what we do. And proposing these reforms and testing if they're effective, right? You know, you know, an example of a question in this space would be, is the rate of publishing our findings higher in studies that are registered than not, or higher in registered reports than not, right? These kinds of tests of, are these reforms achieving their intended aim? Those are really important. And the evidence base is still weak, and there's ongoing efforts that are trying to strengthen the evidence for just to simply, is this effective at achieving its goal? That's one question. But the larger question is not just, does peer registration lead to more null results being reported, but does all of this all of these reforms, does this strengthen the credibility of the literature over time, right? Are we seeing that the claims that are made have stronger evidence behind them, or more honest reporting, or is the evidence for claims properly calibrated? Are we seeing these things improve over time? Because the reforms are not, who knows why, but this need to actually continually assess the credibility of the literature across time and across fields. This is actually the outcome we care most about, right? Is the credibility of the literature increasing over time? But that is really hard to measure, right? How do you measure the credibility of literature, and how do you do it at scale, right? Uh, as the volume of research and the volume of open sharing increases and increases for good reasons, we need better tools to assess the strength of research findings. Um, so what are approaches that people take now? So this is a kind of a stylized table showing different methods, approaches uh, the community takes to assessing the credibility of claims, assessing the strength of research findings. So at the bottom, we have these very quick heuristics about a publication, right? Who are the authors? Do I know them? Which institutions are they part of? Which journal is this claim or finding published in? Right? These are very quick uh, evaluation methods, but we think at the trade-off of accuracy, right? Uh, there's not uh, there's not great evidence to suggest that the impact factor of the journal, or you know the prestige of the author's university, is correlated with credibility, right? For all kinds of reasons. We know that's not it's not a valid um, connection. Beyond heuristics, right? There's light review, so skimming the methods, right? Seeing some p-values, seeing if that looks like strong evidence to your initial impression. That's a little bit uh, more scientifically sound than heuristics. It's a little more costly in time, but still low accuracy, right? It's not the depth of engagement that we would need to really understand the strength of evidence. We go up in this list, right? So heavy review is something like peer review, right? Reproductions, uh, retesting the original claims with the original data, uh, robustness. So can you vary the analytic methods of the original data? Does that produce similar results? Replications, does this effect show up in a new sample? And then research programs, right? These large-scale efforts to not just do one-off replications, but to kind of reassess an entire literature systematically. As you go up this tier, right, where the quality of the evaluation, the accuracy of those methods increases, but at the cost of resources, right? Time, financial resources, and just attention, right? And, researcher focus. So, to a first approximation, there's a trade-off here: accuracy versus resource investment, right? And we face this for a while. But are there new approaches that can help us bridge this divide, right? Can we actually develop and test rapid and scalable and valid methods to assess confidence in research claims at scale, right? So uh, not these large scale investments and large replication projects, at least not all the time, right? And not these very flawed quick heuristics, right? How do we achieve validity at scale? This question was the motivation for a program that was sponsored in the US by DARPA, which is the Department of Defense's kind of research and development arm. So they sponsored this program, Systemizing Confidence in Open Research and Evaluation, which It shortens to SCORE. The SCORE program was early research to test, but develop and assess the possibility of these scalable methods that can achieve similar accuracy to a full replication or a full research program even, but at a fraction of the cost. So the setup of this program, I'll briefly walk through here, right? Like many DARPA programs, it's focused on different functional areas, right, of the research program. They call these TAs, technical areas. So COS, my organization, we were TA1 in this program, and we had two responsibilities. The first was to sample the social and behavioral science literature from a 10-year period, which um, ended up being 09 to 2018, because the project started in 2019, right? So sample papers and research claims from those 10 years in the core disciplines of political science, psychology, economic sociology, and then cognitive disciplines, education, public administration, health research, things like this. So we had a larger sampling process that eventually got us to 3,900 papers across 62 journals in 10 years. Within each paper, we would select at least one finding, sometimes multiple findings. Um, and we would give these research results from this 10-year slice of literature to different teams whose job it was to make predictions about the likelihood of that claim being replicated in a new sample of data, right? So, it might be a political science public opinion finding from, an article in 2012. Could researchers in, well, this would have been 2019, 2020, 2021, could they, in a new sample, retest that finding, retest that hypothesis, and get similar results, right? Doing this across, you know, making these predictions across 300 different papers and claims. These teams took different approaches. So you can see on the slide, there were a couple teams that were focused on human methods of making these called confidence assessments, right? On likelihood of replication. Uh, so one of these, the Replicats project, which people in this group might be aware of, or maybe even engaged in some of this work a few years back, right? This was built around elicitations among small groups of experts about the likelihood of a replication. People would make these predictions both pre and post small group discussion, and then the post discussion human scores were that prediction, right? That 0 to 1 measure of likelihood of replication. That's one of the human approaches. A second human approach was focused on prediction markets, right? Betting markets that have become more common in various fields of prediction tasks. The idea being that participants, who are bettors in this case, right? They're betting on a claim's likelihood of being replicated, and the bets affect the prices, and the closing price is proportional to the same 0-1 score, right? Where a higher confidence score would suggest higher likelihood of replication. And then we had technically four, but organized in three groups, three teams, from three universities, USC in California, Penn State in Pennsylvania, Texas A&M in Texas, and then an industry group called 2-6. And so they were doing a similar prediction task, right? How likely is it to replicate in 0 to 1 scale, but with machine approaches, right? Machine learning. And then on the back end, what COS did is we ended up replicating a small sample of these claims, not a small sample, but not the full not all 3,900 articles. We've replicated a sizable set of these outcomes, and that served as the ground truth, right? To test how valid or how accurate, I should say, are these prediction methods at predicting the actual likelihood of replication success. And just one final note here is that the structure of the program uh, was actually focused on two different relationships, right? It was actually, can the humans predict the actual replication outcomes, right? This is building on prior research showing that replication in some context is predictable. So that the real test was that this TA2 human predictions, can they predict TA1 replication outcomes? And then alongside that, can the machines predict not actually the replication outcomes, but the humans, right? Can machines um, approximate you know human evaluation at again fraction of the cost? Uh, so this was a very large research effort, took place across many years, basically 4 years of data collection, and it's been a couple of years of post-processing, write-up, and all that stuff. The results are coming out soon. We think early in 2026. So I'm not going to show much of that here. It's not actually the main the main focus. But I wanted to show just a couple of findings, a couple of really just figures, and to talk through them. Right. So I'm showing here. This is plotting the machine predictions on these 0 to 1 scores. And again, the machine's goal is to predict the human evaluations, which are along the x-axis. Actually, this is just the replicats uh, um, elicitation scores. And this is across, these are kind of like the names of the team's sort of approaches, right? So A plus is 2 6s, a macro score is USCs, and thematic markets is a combination of PSU and A&M. So what do we see here? Uh, we see that sure, machines do have some ability to predict the human evaluations, right? This is positive relationships, not overly strong, right? Part of this is because of the relatively narrow range that's being used in these confidence scores. So both on the replicats side, right, you can see a lot of the scores are concentrated between 0.5, 0.75. It's a bit of a wider distribution for the machines, but neither of them is sort of covering the whole prediction space. So early results have, you know, some promise here, but still a lot of improvements will be needed. Uh, here's a fuller look at kind of all of these measures in conversation, right? So this is looking at correlations across confidence scores, right? These 0 predictions in the first 6 columns. The last column is the actual replication outcomes. Uh, I've 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 grayed out the bottom right distribution for non-essential reasons. Has to do with something else. But it's nothing shocking there. It's just it's not public yet. But so there's a lot here, right? Showing the correlations among these various measures. But the key is these relationships that the score program was trying to assess, right? So the first is, can humans, which is TA2, can they predict replication outcomes, which is the COS replications? And these two green boxes are equivalent. They're just showing the correlation and the confidence interval with the correlation, and just the actual plotting. There is some ability, right? The human predictions are positively correlated with replication outcomes. Is it incredibly strong? No. Is it something to build on? Yeah, potentially. Right. So from the score, right, there is some ability, humans to predict replications. And then this other relationship, right, in purple, right? Can the machines predict the humans? And um, variations across teams here, but generally, Yep, there is positive modest correlations between the machine and human predictions. And then the real kind of like the real goal that all this research would build towards is in red here, right? It really is, can the machines predict the replication outcomes? That's the most scalable version of this, and that's kind of what the research would be hopefully building towards over time. So weaker evidence than machines' abilities to predict the human scores, but at least for two of these teams, right? A plus, which is 2.6 again, and then macro, which is USC. There's a positive correlation here. Macro is not quite significant, but something, not a lot of evidence yet, but still, that's the outcome of score, right? So the goal of score was not to kind of engineer deployable products, right? This was supposed to be very, very early research, proof of concept, basic R&D. Is there enough to make it to invest more in it, right? Is this actually worth the community's time? And the answer is potentially. We think there's something here that's worth pushing further, but it is, you know, nowhere near deployable, nowhere near ready, right? And so the question that we asked ourselves is, what would it take to actually push this further, not to being deployable or usable quite yet, but to advance this research uh, agenda one stage further. And some things that we'd want to see are more algorithm solutions, right? Not just the 3 or 4 teams that were picked for the score program, but let's open it up to the community and let's ask what can others do on this task, right? Can there be, there's been many years since score took place, and there's been, major developments and improvements in AI models. So what would it look like now, right? And with more algorithm solutions, our hope would be that improves accuracy, but also reduces bias from any one set or one approach that um, certain folks might take. We would also want to see more generalization, right? This was score was pretty narrowly in social behavioral, right? Again, centered around political science, economics, psychology, sociology, but there's a lot more science than just that, right? And so, you know, is this early evidence just specific to social behavioral, or can this be generalized, right? So we want to see this replicated in other fields. We want to learn more about what authors actually use these machine assessments. Are they usable to improve research? Do they even make sense? Or are these just black box models that just spit out numbers, right? Are they actually actionable, right? That's the key. And then finally, we would want to know, well, we don't want to just deploy AI models into the research space. We want to actually talk about the limitations. What can they do? What can't they do? And what is the actual responsible way to use these algorithmic assessments in concert with traditional methods, more human-centric methods? How do we actually make sense of this in a larger ecosystem of evaluations? So, at COS, we have transitioned this research into a new project related, a similar title, Scaling Machine Assessments, Research Trustworthiness. We call it SMART. Um, and through this research, we're uh, trying to accomplish four tasks that kind of align with these needs, right? So the first, that is largely complete. We will release some results soon, was actually having researchers submit papers to the score team's algorithms, right, for assessment, to read the reports that they produced and to see, is this useful, right? Can authors actually make sense of machine approaches to evaluation and human approaches as well, to improve their research. So we got a sample of authors, we surveyed them pre and post, and then showed them reports from the machines and the human prediction approaches, and then asked them some questions about how usable is it. So that's all done, almost done actually, results coming soon. We're additionally collecting more replication evidence, right? This is sort of testing the generalizability into new domains. So we are engaged currently in a replication project, specifically in health behavior, right? This is still social behavioral focus, but it's pushing us further into the public health and health sciences space, right? So this is a similar project to other COS replication projects. This is just kind of narrowly in health behavior research. So I included a link here. If folks want to actually be part of this, either as replicators or reviewers, we would love to have participation from folks. So it's ongoing data collection efforts. Um, we are also in the middle of a public competition focused on machine assessment, where we are opening this up to the public, asking for submissions, and then awarding prizes based on accuracy. And I'll get more to that shortly. And then finally, the last step, which we haven't started yet, is this um, product visioning, right? If this was to become some kind of product or service, either at COS or elsewise, um, we do want to be, like we said, sharing and publishing responsible use guidelines. And so we'll be taking more steps in that direction as part of this research program, probably next year. So more on all this soon. But I wanted to focus for the end of the talk on this ongoing competition. Uh, so from SCORE and a couple other activities, we have a collection of roughly 250 replication outcomes that we have not published. They will be published in, like we said, hopefully January, February, but they're not public yet. And that actually gives us an opportunity, right, to open up these SCORE replication outcomes for one more set of algorithm development and testing. And like I said, we wanted to uh, make this an open call, right? Not just hand select a few teams like we did in SCORE, but actually look to the community and see what it can produce. So we set up this 3-round competition where the prediction task is to predict. So I should say they're given a set of research claims from the same SCORE literature, right? That 10-year period of '09 to 2018. Uh, so they only see the original paper, the claim we selected, and some stats about it, right? The p-value, sample size, effect size, um, and the reference. They use that and whatever other information they want that they can gather themselves from the paper or outside the paper to generate predictions. And the goal is to predict whether that finding that we picked from the paper would replicate in a new sample, and we defined replication for this project as PLSNL5, two-tailed test, in the same pattern or sort of same direction as original findings. So we are doing this over 3 rounds, right, with different replication outcomes each time, right? So the first was this past month, it just wrapped up. We'll hold a second round over a longer period of time. We'll start a couple weeks from now. I'll go through January, and then we'll have a final set later in the spring, right? Uh, Within each round, right, teams can submit up to 3 scores, and the top 3 performing scores in each round get a financial prize. What are our goals here? Well, so part of it is just building out the community of people who are working on this and who care about this. And so, you see these first 3 goals really just about, can we get folks engaged in this, right? So can we get at least 4 different teams to submit scores? It's pretty low bar, but we wanted to set ourselves a modest minimal goal. We want coverage of both academic and the non-academic spaces. And we want different approaches is the word we've used, just different ways of approaching this task among the full set of submitted methods. And then the actual goal of seeing improvement, we want at least a 15% improvement in the accuracy of competence scores relative to what was produced during score. And there's two ways we can think about this, which is, well, the second one would just be the average accuracy. Is it higher with these approaches versus score? And then a different version would be, what was the best method or best methods from score? What's the best method or methods from this competition? And putting those kind of head to head. So first round's done. I will say we have already met the first two goals. We have more than 4 teams submitting. We have teams from both academic and non-academic spaces. We're very, very early into these results. So I'm just sharing what we have so far. And so the main assessment metric that we're using for this is it's a Breyer score, which it basically values two things, right? It values calibration, which is how closely um, basically do the predictions map to the proper probability space. So do predictions of a 0.8 confidence score, those claims should replicate 80% of the time. For claims with confidence scores of 0.3, those should replicate 30% of the time, right? So how well do the scores map to actual probabilities? That's calibration. And the discrimination is uh, how how well do high and low values of the confidence scores distinguish replication success, replication failure? Okay, so you're seeing uh, basically the best performing method from each of the teams in the competition. I've included just initials for anonymity, as well as the 3 teams from score that we discussed, right? So taking their scores into this competition. Uh, Lower scores are better in this context. And so what we see here is none of the competition participants did as well as the score participants. Differences are not huge here, right? Especially at the margin. But from this, at least, we don't see major improvements. But the more notable thing and the more disappointing thing is that if every prediction was just 0.5, which is essentially no information, the resulting Breyer score would be 0.25. So only one of these teams is actually doing better than just 50-50 guess each time, right? And even that isn't by much. Uh, so what you can say from this is the competition teams are doing about as well, maybe a little bit worse than the score teams, but none of it is really a huge improvement over just a guess of 0.5 every time from this. I will show a second view of this, which is a measure of accuracy. This is a little bit different. This is looking at those confidence scores and specifically the 0.5 midpoint and asking, uh, an accurate approach would say that when scores are above zero point 0.5, the claim is more likely to replicate. That would be kind of a 1 in the scoring. And if they're below 0.5 and they don't replicate, that's also a success, right? Shouldn't replicate and it didn't. And then failure would be scores above 0.5 that don't replicate and below 0.5 that do replicate, right? So looking at accuracy, we still see that A plus, which is the 2.6 organization, that still outpaces everyone else. But now we actually do see a bit of improvement. In again, all these initials are competition participants relative to some of the score teams. So a little bit more promising on accuracy. None of this is overwhelmingly positive, right? This is still early and preliminary. And then the last one I'm going to show is this is looking at not replication outcomes, but looking at the machine predictions predicting the human assessments, right? And so this is just a correlation measure. Higher correlation's better. And again, actually, we're seeing some better results. At least three of the teams in competition outpaced the best team from score. Again, these are not huge differences, but some signs of progress. Again, all this is very, very early. It's as of this week, so there's more to do on these before we would actually be confident in any of these assessments. Okay, so just some early takeaways. So competitors seem about on par with score, maybe a little bit better on some metrics, a little bit worse. Um, no methods are what we say are so far, sufficiently strong to say this is close to a finished product. We're far from that. But the variation across competitor outcomes and scores suggests that there are better and weaker approaches here, right? So the variation suggests there are things in the stronger methods to build upon, uh, and we could hopefully see improvements in this in future rounds. So our next steps are just a more careful analysis of round one data. We will share these results both with the participants and publicly, and then we'll think about what makes sense for round two. The default would just be rinse and repeat, right? So same process, just different application outcomes. A different approach, if we wanted to play with it, would be, maybe we could show more information about the actual replication attempt to participants. Right now, all they have is the original claim. They don't know about the design of the replication. Could we feed details about that as part of the prediction task, and would that improve things? Or is that defeating the purpose? So just things to think about for how to maximize kind of round two based on what we learned in round one, but we still have to sort of see what we did learn from round one. So a little preliminary. Okay, that was a lot. With that, I will take my pause and I will stop sharing for now, and I'll see if there are any questions or any comments or any feedback.